Hello, everyone. This is Belinda Carr, and you're listening to my podcast on building science, products, and technology. As we know, the construction industry is ripe for automation and disruption. It has been reliant on manual labor and outdated tech for far too long, which has led to lagging productivity. Every week, I chat with a company that is exploring ways to tackle these issues. Today, I'm speaking with Gaurav Kikani, Vice President of Strategy at Built Robotics in San Francisco. Thanks for joining us, Gaurav.
Thanks for having me.
I am very, very excited about this podcast because 3 years ago, when I first began my YouTube journey and started researching automation in building construction, your robotics technology and robotic excavator was one of the first products that I reviewed, that I researched and reviewed and made a video on. And it's almost like that excavator sparked this curiosity in me for what's the next thing in the construction industry. How can we evolve? What are we doing wrong, and how can we do it better? And that curiosity is what drives me to do things nowadays. So I'm again very, very excited to talk to you about Built Robotics and learn more about your robotic excavator.
Yeah, no, I'm so excited that we've come full circle, and I think we have a lot of new stuff to share.
Yeah, absolutely. So for anyone who's hasn't heard of Built Robotics, is it fair to say that Built Robotics can transform any excavator into a trenching robot?
That's correct.
That's a one sentence summary of a very complex and very complicated company.
Absolutely. Yeah, no, I think you hit the nail on the head. But basically, yeah, we take existing heavy equipment like excavators, and we can basically enable fully autonomous operation of that. So, of course, these machines have been around for 100 years. It's the way we build everything. Caterpillar is a household name. Everyone knows what we're talking about when we talk about that. But the way that we use those tools hasn't changed, and it hasn't changed for a very long time. And now, when you think about the labor shortages that we're seeing in developed countries around the world, and then you layer on this massive need for new infrastructure that all of us need because everyone's using more internet than ever, more energy than ever. We need drinking water, we need kind of sanitation. All of that happens because we're able to move dirt and materials in an effective way and build the infrastructure the world needs to survive. And so, what we're trying to pioneer are new methods to build. And by allowing ourselves to take experienced humans who have really, amazing skills, but applying them to the things that humans are best at, which is making judgment calls and decisions, and fine motor skills, and automating the basic and repetitive tasks. That is really how we're going to get enough productivity as a society in order to build everything that we need in order to survive.
That's a beautiful way of putting it. Like, we have the knowledge to do the fine motor skills. Let's focus on that, and all the manual labor, the repetitive skills, let's just delegate that to the machines. So before we dive more into the company and your journey at the company, let's talk about you. How did you get to Built Robotics? How did your passion for automation grow?
Yeah, I find these questions really, really fun because, on one hand, you can kind of paint the story and it can sound like everything I ever did led to this moment.
You have such
Um,
a clear path, right?
right. But I think there's a lot of serendipity and a lot of exploration along the process. But maybe just starting from the origin story, I kind of grew up in Houston. My father's in the oil and gas industry, and so I always grew up with a bit of a fascination around how how do humans, while we are fairly proficient at a lot of things, as an individual species, we're not that good at a lot of things. We're not the most strong, we're not the most powerful, but what we can do when we kind of come together and use our ingenuity is these incredible building these incredible engineering feats, and that's really what society's been built on today. And so, having a dad in the oil and gas industry, I was always kind of hearing these stories about how they were drilling, 50 miles under the ocean and, using all this technology in order to extract the gas or the oil or the energy that we need. And so that's really where I think that appreciation kind of started. After that, I went to school at Northwestern in Chicago. I studied economics, finance, math. I spent a few summers on Wall Street, did the whole finance thing, And then I realized for me, measuring value was not as kind of fulfilling as creating value. And so I wanted to go build things. And um, after that, I did a stint in consulting at Bain. I worked on mining and technology companies. So again, some of those threads came back where I got to work with large Fortune 500 corporations that were very focused on the kind of physical world. And then from there, I actually joined a financial firm in the Northeast. But one of the unique things we were doing there was actually company creation. So we were actually launching startups in spaces that we thought we had a differentiated thesis on the market. And for me, that was like a very validating moment where I had a hunch I liked building things, and I got to be a part of actually launching two companies, working with the founding teams to actually get them off the ground. And for me, that was exhilarating. I loved being on the ground floor, rolling up my sleeves, and every day was a new fire or a new challenge.
That's when it
And
clicked. You're like, this is the field I need to be in.
yeah, that's what I wanted to do. So I around that time I met Noah, the founder of Built Robotics, and this is back when all the company had was a prototype. And a small team. And so I joined the company to help build the business and kind of think about the commercial aspects of the company. And this was back in early 2018. So a lot has happened since then. We're now actively operating in the US and Australia. We have robots commercially deployed on construction projects being used day to day. And the technology works. It is a reliable tool. And now it's all about how do we get more robots into the hands of people and get them using this new technology to transform construction. So
It's a
that's a little bit on the journey.
Yeah. So I remember in 2018, there was this viral video that came out on Built Robotics. It was a father and his daughter, and they went out on this job site, and there was this robotic excavator there, and they turned it on, left the job site. It was running all night, and then they came back the next day, and the job was done. And it conveyed the message so well that it's just and that was just a very powerful and probably viral ad. Was a good thing for your company too. I'm sure your technology and hardware and software has come a long way since then. Like you said, you had a single prototype, but you've developed it into this massive ecosystem now. I went on your website and you all have so many different components that I hadn't seen back in 2018. You'll have the exosystem, the Everest, the field kit, the Guardian. Let's dive into each one of those and explain how this whole ecosystem of Built Robotics works.
Absolutely. First off, that video that you mentioned, still my favorite video I've built. It really pulls on your heartstrings.
Yes.
But you're absolutely right. If you compare that video with our latest product videos, there's a night and day difference in terms of the sophistication. And we've had to consider all of these different elements about what goes in to having a kind of successful deployment of automation on a construction project. And I think one of the things that we've thought a lot about and have feel responsible for is it's one thing to drop a robot off at someone's doorstep and say, here, we built it, use it. It's another to provide all of the tools you need to be successful, all of the training, and kind of considering that we're trying to insert a new tool into a very complicated operation. Construction projects are complex. They require a lot of sophistication. And so I think recognizing that, we decided it's also our responsibility to build this whole set and platform of tools that can make anyone successful in running these robots. So yeah, to answer your question, we can go through them one by one. So the kind of core of the platform is the exosystem. And the exosystem refers to this artificial intelligence guidance system that we basically take existing heavy equipment. Today, our focus is excavators, but we have worked on bulldozers and track loaders and other types of equipment. So you take this heavy equipment that already exists and you upgrade it with sensors, a ruggedized computer, GPS, the suite of sensors is really important because the robot needs to be able to sense its environment. And so the exosystem is basically this all-weather enclosure that we basically physically mount to the equipment. And that enclosure houses all of these sensors and components. And it ties in to the existing electronics on these machines. And so basically, the way to think about our product is just like a human operator is using their ears and eyes to observe their environment, they're kind of getting all this data using their senses. We have sensors that we install on the equipment that are doing the same thing. So, hundreds of thousands of times a second, you're gathering all this information. And then you're using that information to make intelligent decisions. And that's the full autonomy that our robots are able to do. So now a human has used their senses, they've collected this information, now they're using their brain to make decisions on how to move the joysticks of the machine and have it operate to accomplish a task. The same way our computer is taking all that data from the sensors and using our software in order to make those intelligent decisions on how to actuate the equipment fully autonomously. So that captures the exosystem component of our product. This is the core. This is kind of the machine learning and deterministic algorithm side of Built Robotics, which is like the core technology.
This is kind of dumbing down your very, very complex technology. And excuse me for saying this,
Yeah.
but I'm thinking of the analogy to the movie Ratatouille. A little rat that sits on top of a human and dictates how things are done. So your Built Robotics ecosystem is that little rat that knows where things are supposed to go, how things are supposed to be done, and the human is the dumb, age-old excavator that we're using out on job sites. So we are converting a dumb excavator into an intelligent excavator.
That's right. That's right. So I think I think Ratatouille is a great analogy. So that rat was sort of orchestrating, and that human chef in the movie, that was the person who is the channel or the conduit to actually getting that work done. In our case, exactly, that computer and the software is making the decisions, and the excavator machine itself is the means by which the work is being done. That's a great analogy for what we do. Yeah. And actually one more layer actually to add to that analogy though, is that a human operator is still a critical part of this system.
Yes.
So we can talk about this in more detail, but maybe a quick summary is you still need a human to supervise robots. And so we've actually devised a new class of work that's emerging. We call it a robotic equipment operator, or an REO. And those REOs are responsible for kind of setting up the robot at the beginning of the day, telling it what its task for the day needs to be, and then kind of pressing go, and then sort of maintaining and supervising a fleet of robots now. And so these REOs are really, really important. It kind of comes back to what I was saying about humans doing what humans do best, which is being a thoughtful supervisor, thinking about how the work needs to be sequenced, where should that robot be working, are we done? Are we getting too far ahead of the human crews that need to follow it, and making all of those intelligent decisions? And that's what the REO is super, super important for. And so I think Ratatouille is a great analogy, but then there's like this third layer that comes in, which is the REO, and I think that's important too.
And your this exosystem box that you'll put on top of the excavator and any other machines, it also has these proximity radars around it, which, because on your website, you all say safety is first, second, and third. So y'all are, even though y'all are trying to transform these robots, y'all are still concerned about the safety of humans out on job sites. So in case like humans trespass a barrier that's set up on job sites, this excavator can spot a human within a certain distance and then stop, right?
That's exactly right. So again, think back to how do these machines work today with humans? It's humans using their eyes to see people. If they see someone come close to the excavator, they're going to stop and they're going to protect that person. So we needed to make sure when we architected the system that we also preserve those safety fundamentals. And it's the same thing. So we use cameras and machine learning in order for the robot to be able to see a human and detect that they're there and stop right away. But at the same time, we recognize that technology is, it's a work in progress always, and it can always be better. And so even though our robots and the pedestrian detection systems are pretty much on par with how good humans are at perceiving people, we think we can't stop there. And so we've actually introduced an 8-layer safety system. And detecting humans is just one of the layers, but we also have safety barriers, like you mentioned. We have a geofence, we have wireless and wired e-stops. We have Guardian, which we'll talk about in a second. And so all of these layers kind of come together, and we kind of view it as we call it the Swiss cheese approach to safety, which is, how Swiss cheese has little holes in it. You we don't want any holes to line up in our Swiss cheese, because then something can pass through that. And so in our safety model, we have so many layers of safety that even if a few layers have small holes in them, those holes will never line up in a way that a safety incident could actually happen.
And
And
I
so
guess
that's
this
why.
is really
Mhm.
important in the early stages when people are so curious about the technology, they want to get closer to a robot. In time, people will understand the need the importance to stay away and all. But in the early stages, when people aren't as educated on how the robot works and their interaction with the robot, it's extremely important.
Absolutely. And we think that if someone asks us what keeps us up at night, it is, how do we keep people safe? Always, full stop. New technologies are interesting and fun, but they're of no use to us if they inherently make things less safe. And our argument actually, and our belief is that robots and autonomous equipment will actually make construction projects safer,
Yeah.
because they are more predictable, they're more consistent. They don't make judgment calls. They don't kind of decide to try something new, or think that they can do something that they can't. Robots will always work the way they were built and programmed. And so for that reason, we've made sure that when we program them, we put a lot of safety layers into place, to make sure that people are always safe around them.
That's awesome. So the second component of the system is called the Everest, and that's a robotic operations software.
Yeah. So when you think back to what we were talking about, is you have this computer that actuates an excavator, and then you have a human who has to supervise the robot. Well, how does the human talk to the robot? And that's where Everest comes in. So Everest is a user interface. You can pull it up on your laptop. It's an app basically, and the REO can fire up that app and connect to the robot, and then they can use Everest to give the robot instructions. So what does the robot need to do today? Where is the geofence? What is the area that the robot has to operate in today? What are the specs? How deep does the trench need to be that you want to dig? Where do you want to put the material when the robot's digging? So those are all decisions that the human is going to make. They're going to kind of basically give the robot some homework. They're going to give it an assignment. And you have to tell the robot, this is what I expect from you. And you can use Everest to communicate with the robot. That's kind of part one. And then part two is Everest is also used to monitor the robot. So you have live video feeds coming off of the robot, so you can see it in the app, exactly what the robot's doing, what it's about to do. You get all kinds of data, so you can see how fast is the robot producing, what time will it be done with the project that it's been given. And then finally, there's a lot of telematics information and kind of machine information that you can also get from Everest. So
And
if you think about,
telematics means,
so
sorry.
telematics is like information or data that you can get from a piece of equipment.
Okay.
And so, fuel levels, engine temperature, hydraulic pressure. So these are all important pieces of information that a human operator would get if he or she was actually operating manually inside the cab of the equipment. And so Everest is another way that you're not in the cab of the equipment anymore because the robot is autonomous, but you can still monitor all of these really important machine information from the Everest dashboard. And so it's a really cool way. You can monitor multiple robots all at once. And so you could be sitting, somewhere else. You don't even have to be near the robot. You can be sitting in your office, pull this up, and see exactly what the robot is doing wherever it's operating.
So are there degrees of intervention when it comes to Everest? Like, for example, out on a job site, can you can the robot itself figure out how much needs to be excavated in a certain area and go do it? Or do you have to dictate exactly how much has to be excavated at each point on the job site, and the speed of it and all that stuff? Is there how much manual intervention is really needed?
Not much. So just like any other construction project, if you have a human operator, someone needs to tell the human operator what needs to be built, right? So, hey, you need to dig a trench from point A to point B. I need that trench to be 3 feet deep, and I need the material to be put 3 feet to the side. That's it. Um, that's exactly what you would tell the robot. You would tell it where you need the trench, what you need the trench to look like, and then you press go. That is all the, I guess, instruction that the robot needs. There's no intervention necessary because the robot will then figure out, okay, I've been given this task. The robot will survey the earth on its own and figure out what does today's world look like? And then what do I need to do to turn today's world into what the REO told me to do? And the robot does all of this planning on its own. And so it'll figure out this is how many scoops I'm going to take. This is how I'm going to approach the dirt. This is the angle my bucket's going to be at. As it's digging, it's also replanning and it's updating its plan and saying, wow, I'm getting a little more resistance from the dirt than I expected. I should change my bucket angle and I should attack it a little differently. All of that is being done on its own by the robot. And
Oh,
that's what
wow.
our software, it's very powerful. It's able to react to a very dynamic environment. And that's actually one of the cool distinctions actually about our technology is that unlike self-driving cars or even self-driving trucks, um, what we're doing is essentially manipulating our environment, right?
Yeah.
The excavator actually digs and it's actively changing everything around it. And so, unlike in self-driving cars, you're driving on a road, you are not trying to interact with the road at all. If you interact with the road, it's probably an accident, right? And so that's kind of the unique nature of what we're doing, which is there's autonomy and automation, but there's this kind of manipulation of your environment. That's the robotics piece of what we do, and that's why it's really cool intersection that we
And what's
find ourselves in.
more difficult to me is that each job site is different. Soil
Yeah,
conditions are different. And even within a particular job site, some areas can be rocky, some areas can be clay, sandy. It's just there's so much more unpredictability, even though the site is more confined than large stretches of a road.
that's a great observation. That's exactly right. And I would say that a lot of people compare construction to mining and agriculture, the sister industries that have seen probably more automation
Yes.
than construction to date. And I'd say one of the biggest variables is what you said exactly, which is construction projects are shorter in duration. Maybe they're 6 months or 12 months, but once you're done, you move on. You go to a different site and it could be totally different conditions.
Yes.
Whereas a mine, once they build that mine infrastructure, it's there for 25 or 50 years and you can just keep working in the same area. Now, of
Or
course,
even with agriculture, it's seasonal or yearly within, but again, they're working within a certain area year after year.
correct. There's
Yeah.
some element of permanence. I
Yeah.
would I'll concede that agriculture and mining also are fairly
Yes.
dynamic because you are manipulating your environment, but I'd say construction is the most dynamic of all of them. And so for that reason, we think that this is actually a very complex software problem. And that's why, we spend a lot of time developing and honing this really powerful software that we've created.
Absolutely, because I was looking at your website and I was trying to figure out y'all aren't a software company, y'all aren't just a hardware company, y'all are like an ecosystem. Y'all are tackling so many things at the same time, and y'all have to constantly evolve based on the feedback that you're receiving, both from customers, both from different job sites. For example, if you all test your software out or your hardware out too in California, you'll get certain amount of feedback, and then you'll bring it to Texas or bring it to the Northeast. You're going to get completely different data. And
Yeah.
how do you integrate all that into the software? Like, does it ever get bogged down? Have you all thought of having site specific software? Or you talked about
Yeah.
going to Australia too. I bet that's a whole different uh, world to tackle.
Yeah, I mean, this if you ever spend a day at Built Robotics, a lot of our conversations are about this, is what is a feature that's worth building versus what is something that is very site specific and sort of idiosyncratic. How do you make the decision whether this is worth building out or solving, or this is the right way to solve the problem? And ultimately, our guiding philosophies are, one, it has to be easy to use. It has to be a delight to use. This technology cannot be scary. We need it to be intuitive and a reliable tool that people are feel confident using, because construction operations are already complicated. We don't want to make them more complicated. This tool should simplify things. So that's point number one. And then point number two is that we basically want to find the simplest way to solve problems. I think that's where a lot of robotics companies, especially, get bogged down, is that in order to find perfection, they actually never ship a product. And that's how a lot of robotics companies have gone out of business. And so Built really prides ourselves. I think we're probably the first field robotics company to have like a commercially viable product in construction. And you know, it works and it's reliable. And the third philosophy is that it needs to be generalizable. It needs to work the same way on any job site, and we need our software to be powerful enough to be able to adapt to the job site conditions. If it is a finicky product that needs to kind of change every time you take it somewhere new, it's going to be really hard to make this a scalable technology that is used all over the world. And so that's kind of, those are like the three philosophies that inform a lot of our decisions as we make the product.
It's so complex because, like you said, the product has to be easy to use. It can't be too complex visually to look at, or even to use. But behind the scenes, it's like chaos. It's like constant feedback coming in from all around the world, and trying to incorporate all that into this. It has to be a robust technology. It's in, like I said, it sparked my curiosity in this whole field 3 years ago, and it's just wonderful to see how much y'all have evolved since then.
Thank you. Yeah. Yeah, it's been quite a ride. A lot of testing, a lot of learning. And I think that's, one of the values that I think actually helps facilitate all of the philosophies I just talked about is just humility. Is just
Yeah.
saying that, look, we might not have all the answers today, but we're going to keep learning, and we're going to keep our eyes and ears open. And any feedback we get, we're going to figure out how to channel that into a better product. And that's how we avoid stagnation, and we're always pushing forward and making this better. And honestly, that's why the product looks so different 3 years later, is because we've taken that approach on not just sitting around and saying, okay, we're done, wipe our hands. We always have to push into the next level.
Keep evolving. Yeah. So the other two components, we cover the exosystem, we cover the Everest, but the other two components of your whole kit is the field kit and the Guardian. And the field kit is a robot operations toolkit.
That's exactly right. So field kit is what I was talking about earlier, which is what are all the other tools you need in order to successfully deploy a robot. So there's a ruggedized laptop in there. What is the REO going to use to pull up Everest on? Well, they need a laptop. Well, okay, this laptop needs to work on a construction site that's dusty, and it's getting shock and vibration and extreme temperatures. Okay, well, we've spec'd a really high-tech laptop that will work, that'll last, that can take the beating that these devices take in the field. That it's not rocket science, but it's really important to the user experience that we've taken the time and the diligence to source the right tool for the REO to be able to use our software. There's other examples like, well, how are you going to charge this laptop when you're in the field? Well, the REO needs an inverter probably. Well, okay, what are they powering their inverter on? Well, they probably need a little field vehicle. Maybe they're in a pickup truck, or maybe they're using a UTV to get around the site and manage all these different robots. Okay, what is it? So suddenly you start to ask all these questions of, it's one thing for me to say, here's the robot, use it. But there's a whole user journey and user experience that we need to think about. And we need to figure out what is the most delightful way, the easiest way to kind of facilitate REOs using this technology, and honestly making our REOs rock stars. Being efficient and productive and unlocking all of this value and building the things we need to build. So, we've really taken great pains to design that whole user experience.
Yeah, absolutely. And you also have it's not an ATV, but it's a UTV. It's a I'm not sure how I would describe it, but
Yeah.
what do you use a UTV for on a job site?
Yeah. It's like a rugged golf cart is maybe the best way to explain it. It has a diesel engine. Ours has a diesel engine. It has rugged wheels, tires, and it's able to get around off-road very conveniently. So imagine you're an REO, and let's say you're managing a robot, and you also are, manually operating a bulldozer at the same time. So you'll start your day, you'll drive your UTV out to the robot, you'll fire it up, you'll tell it what it needs to do, you'll press go, robot starts to work. Now you jump in your UTV and you go to this bulldozer. Now you jump in the bulldozer and you're manually operating, kind of supporting the excavator, the robot as it works all day. So it makes the REO mobile, which it's a new way of working because up until now, the operator only ran one piece of equipment. But now this REO can do multiple things in a day. And so making sure that they're mobile and they can get around these large, vast job sites. Imagine a solar farm, right? These are,
Yeah.
it's a 50-acre solar farm. Well, maybe your robot's working in that corner and you're working half a mile away. You need an efficient way to get around and be able to do all the things you need to do. And so that's what the UTV would be used for.
So do your clients like that y'all have this whole ecosystem of products and technology? Do they usually opt for all of it, or do they usually just pick the ecosystem and that's it? They're done.
Yeah, I'd say pretty much all of our clients actually
They do.
like to use the full suite because it's so designed for this brand new workflow
Yeah.
that a lot of people are still learning how to implement and deploy. And so it has made it a much more seamless experience for our customers. And ultimately, the thing that matters the most is how do they get the most value out of this new tool, right? If they're going to take the pains to adopt it and embrace it, then they need to you got to go the full way and actually figure out how to get the most value, get utilization out of it, and that's how you impact your bottom line, impact safety, and become more productive. And so yeah, they typically always use it. Sometimes our partners do have their own UTVs, and in that case, we're happy to sort of modify their UTV or help support them to use the tools they already have in their fleet. So there's no requirement to use Built Robotics's, but we provide the option as kind of like a full suite white glove service that like, hey, we'll take the thinking out of all of this for you, and you can just focus on doing what you do best, which is building and constructing, and we'll help you use this new tool.
When you all got started, did you all have plans to build your own custom robotic excavator, and then you all evolved and realized it would be better to make something that retrofits all the existing excavators that are out there in the world?
Yeah, we might have debated it a little bit, but it was pretty clear to us very early on that you know Caterpillar, Komatsu, Volvo, these people have already built really, really good machines. They're the world's best at manufacturing heavy equipment. And over 100 years, this equipment's gotten very sophisticated, very rugged, it lasts, it's durable, and it's reliable. So why change that?
Yeah.
So for us, it was that platform exists, let's piggyback on it. And now we'll focus on more of the software pieces, the how do you make the intelligent decision making, use machine learning and artificial intelligence. That's what we do best. And then the hardware component of Built Robotics technology, the exosystem, that's the connective tissue. That's how we connect our software to the hardware that these big OEMs have been making. And I think, one day I imagine that a lot of the hardware and the sensors will come baked in from the factory, and Built Robotics will really be that operating system or the software provider across all of construction.
And Built Robotics actually works with all these other brands, right? It's compatible with Caterpillar and all the other brands that people use around the world.
That's right. And so that was strategically very important to us that we don't want to be telling people what equipment they have to buy. We will make our technology compatible across OEMs. We are agnostic to that. And it's a pretty simple upgrade installation process. And then there's a little bit of a calibration that we do for each machine. But yeah, we can install it on a variety of makes and models.
Do people opt to purchase all these systems, or do they rent it from y'all?
So we actually, our model involves a rental of the hardware. And the reason for that is the rate at which the hardware is improving is so rapid. If you think about every 3 or 4 months, there's a new LiDAR sensor or a new camera on the market. And so we want to make sure that we're always providing the best to our partners and they're using the most reliable system. And so today that is the model. Now, longer term, as I think a lot of these technologies mature, it's possible that we move to other or explore other models. But today it is the hardware is rented. And then the software is kind of on a usage basis. So each hour you use the software in autonomous mode, that's what you're paying for. So if you don't use it, you don't have to pay for it. And so we think that that's really important flexibility for our partners too.
So you said in the beginning of our conversation that you all have worked on projects all around the States and in Australia too. How many projects and what areas of the States have you all worked in?
Oh, we've worked all over, in the Midwest, the South, California, up north. In Australia, we typically work in Eastern Australia and Queensland. I think the types of projects are helpful here. So a lot of large infrastructure projects, greenfield in the middle of nowhere. So imagine large solar farms and wind farms. In Australia, we're working in a gas field where they have large pipelines that are going from the gathering wells to the ports, and the processing facilities. And so basically, imagine places where it's really hard to get people to, and you have large projects that involve a lot of repetitive work over long periods of time. So we've worked on probably close to 30 projects now, but the projects vary in duration. We've had some projects that are maybe 2 or 3 months long. We've had some that are over a year long. There's one that's going right now that's 7 years long. And so, I think we've moved a lot of material with these robots, and it's really cool to see this, that scale of impact starting to really accelerate across all of these projects.
So, what are the future goals at Built Robotics for this year and for the rest, like for the next 5 years or so? How do you see the company growing and evolving?
Yeah, I think our North Star is really kind of, we have a product that works, it's safe and reliable. Now it's about putting it into more people's hands and making it more and more useful for them. So particularly the trench excavation application that we really focused on up until now, that is in customers' hands. They're using it every day, without Built Robotics on site. Like they know how to use the robots effectively, and they're doing that every day. So that's kind of goal number one, is continue to accelerate that and help more people get their hands on this technology. Goal number two is actually starting to consider what's next. What's the next application that we can automate? How do we build more useful features for our partners so they can get more value out of this tool? So I think over the next year or two, you'll probably see, the excavator platform. Excavators are very versatile tools. You can do a lot with them, not just digging trenches.
Yeah.
You can load trucks, you can put other attachments on it, compact. And so we're going to start developing a lot more of those applications. And then we're going to broaden into other platforms too. So we've already done some work on autonomous bulldozers. We'll do more there. Compactors and motor graders. There's a lot of different construction equipment out there that we think can be automated, and we think we can do it very quickly. So I'd say in the next 3 to 5 years, you're going to see an explosion of autonomous equipment on construction sites, a lot of different applications. And once all of those have been automated on the unit level, the next big frontier for us is automating on kind of the fleet level, right? How do you orchestrate an entire job site from like a control tower? Like think about air traffic control, right? Those guys are sitting in the middle of the airport and they're orchestrating all of this traffic around them. And imagine if you could do that autonomously with software. That's kind of what we're after here.
Oh, that's exciting. And I bet the pandemic and the labor shortages that we've experienced over the last 2 years has really accelerated interest in your technology and your company. You're probably receiving a ton of requests for demos and just over the last 2 years.
Yeah, I think that's right. For better or for worse, obviously, I think the silver lining of the pandemic is that I think it has reminded people that we do always need to be looking about ways to build better. And we are very reliant on our infrastructure, our highways, our roads. Think about the supply chain issues that are going on right now. If we don't start investing now in thinking about how are we going to prepare for the future, I think the reality is we need all the help we can get. And we have some amazing, incredible, talented operators in the United States as well as other countries around the world, and we still need them. But they need help, and they need more tools. They need, the best tools in order to go out there and build the world we need. And so I think that's what our technology is meant to really augment the human workforce. I think a lot of people worry that we're going to replace them. I really don't think that's remotely near the truth. I think in the next 5, 10, 15 years, you're really going to see more work than ever before as we prepare for climate change, big levees, dams, all the earthworks that needs to happen. We're going to need new methods to do that.
Oh, it's been wonderful speaking with you, Gaurav. Thank you so much again for sharing all that information about Built Robotics with us. What's the best way to contact your company if anyone's interested in buying or renting your excavators?
Yeah, go to our website, builtrobotics.com. It's a treasure trove of information. A lot of what I talked about today is covered there. And there's a contact us link as well. And feel free to shoot us an email and we'll get back to you shortly.
Thanks again, Gaurav. I'm going to link your website and Instagram page and everything in the description. All right, I'm looking forward to seeing everything that Built Robotic continues to produce, and I hope to see your excavator out on job sites here in Texas soon.
Thanks, Belinda. It's been a real pleasure.
Thank you.